Hello 3D printer enthusiast, this is the SmartAlu, and if you saw my last video, you'll remember that I was not impressed by the quality of this machine. Well, as it turns out, Smartfriendz seems to be shutting down, and that kind of explains things why support has been so poor for this printer and why there seems to be no love in the design of it. So now that support is off the table, there are still people who have these printers, and I'm going to make some videos about how to fix those printers and make them better. This is the first video in a series where I will try to remedy some of the design issues with this printer. In this episode, I will do some work to resolve the mechanical issues with the build plate. This massive build plate, which is 4mm aluminium, has all of its weight supported only on one end, so the front of the build plate is almost 2mm lower than the back. The build plate also has a tendency to vibrate during infill movements, resulting in a loss of print quality due to the mechanical issues. I did my best to capture the vibrations on camera, and here you can clearly tell the difference between the smooth auto-level movements, which are compensating for this 2mm drop, and the vibrations caused by the infill. There was no Z-lift enabled here, so all of this is just the build plate vibrating. In order to plot the vibrations, I used a free app called Vibe Sensor and placed my phone on the build plate and hit the record while performing infill on the model. Here is the data, and it shows that the vibrations occur between 16 Hz and 19 Hz with a power spectral density from 0.015 to 0.04 meters per second. I'm not going to get too caught up in the PSD accuracy. It's not really that important. What is important is just having a consistent method of capturing and plotting this data. The first test I did was to add a third linear rod to one side at the front of the build plate. I modeled and printed the necessary parts and reran the vibration test. It did show a reduction in Z-axis vibrations, but it wasn't the fix I was looking for. I decided to add a second lead screw to the front center of the build plate. For this fix you will need an additional lead screw with an 8mm diameter and an 8mm per revolution travel. Be sure that it's 8mm per revolution and not 12. I removed the build plate and drilled a 10mm hole exactly 315mm from the center point of the rear Z-nut. These measurements are based on my printer's dimensions when assembled, so your mileage may vary. I then designed and printed a bracket for an additional Z-stepper in the front center of the printer. This is mainly because I didn't have a long enough Z-rod lying around to mount the stepper underneath the base of the printer, which is what I will do later on. You need to split your signal from your rear stepper motor to the front stepper motor, for which purpose I made this little PCB out of proto board. This plugs directly into the MKS board and both the stepper motors then plug into it. You can reverse the polarity on any of the steppers to make them turn the correct way. I then reran the infill tests that I ran earlier with the same models and the same densities, and here are the results. So as we can see, there is significantly less vibration of the build plate. This is obviously expected as we've added another threaded rod to the front of the printer, and the graph also shows reduced vibrations in the 16 to 19 Hz spectrum where it was observed before. All in all, this was a success. I will be replacing the rods with some 8mm travel rods as opposed to the 12mm travel which I'm currently using, and I will also be getting a longer rod so that I can hide that front stepper underneath the build plate. Thanks for watching, and be sure to give me that thumbs up if you liked this video, or the thumbs down if you absolutely hated it. And I'll be doing some more videos about making this printer better.